Hi guys. So today we are going to look at both the log and the exponential parent functions and then look at some transformations and how those affect the graphs. Now one thing that you're going to want to take note of is that the log and the exponential function are inverses of each other. So if you remember, inverses are when you switch the x and y. So they're going to be kind of similar to each other. The only difference is the x and y's are going to be flipped. So let's start with the exponential parent function. So if you remember from Algebra 2, the exponential parent function is going to be some base with x as an exponent. So that base can be different numbers. It could be 2, it could be 10, it could be 5. So whatever the base is, that's going to affect how your graph looks. So the way this graph looks, it has a horizontal asymptote at y equals 0, and then it has a shape that looks something like this, where one end is getting close to that horizontal asymptote, and the other end is going up towards infinity. Now, this is the shape assuming that the base is greater than 1. Now, if you had a base of 1/2 or 1/3, then your graph would look different, but we're not really going to focus on those today. We're just going to look at if the base is greater than 1. On this graph, there's really one point that you need to be able to graph accurately, and that's what's called the pivot point. That's going to be this point right here that's starting off at 0, 1. So whenever we do our transformations, that's really the only point that we're going to transform. So what you'll need to do is find that point, find your asymptote, and then just get the shape of your graph correct. Now you'll notice the exponential parent function, like we said, it has a horizontal asymptote at y equals 0. So that affects our domain. Because that side of my graph is going to get closer and closer and closer to 0, then our domain is going to be everything because that doesn't stop our domain. That does stop our y values, though. Our y values are not getting any smaller than 0. It actually doesn't touch 0 either because of that asymptote, so we need a parenthesis on 0 as opposed to a bracket. All right, so now let's look at the log parent function. The log parent function is the inverse of this function, which means all of our x's and y's are flipped, which means the pivot point, instead of being 0, 1, is 1, 0. Now, the reason that's our pivot point, again, if you plug in 0 for your x, it doesn't matter what your base is. You're going to get 1. That's why it's the point that we're looking at. So same thing with logs. It would work out the same way. All right, our asymptote then as a result too is also going to be flipped. So instead of y equals 0, it's x equals 0, which means that it's a vertical line for our asymptote. So a good way to kind of remember that, think about logs. They come from trees, and trees grow up and down. So your asymptote for log is vertical. So your graph will have a similar shape, goes towards the asymptote on one side, and then goes away towards infinity on the other side. So again, domain and range here are also going to be flipped. If you look at the domain, the asymptote here is stopping the domain. So my domain is from 0 to infinity, whereas my range is from negative infinity to infinity. So these two graphs are very similar, but again, the x's and the y's are flipped. All right, so now let's look at what transformations will look like. So we're not really going to look at stretches and compressions on these graphs. It's a little bit too hard just because the base can change and it could make a difference in our graph. So we're really just going to focus on shifting and reflecting. So we're going to first look at what this will look like for an exponential function. Now again, the base can be anything, but I'm going to keep the base consistent just so you guys see what it looks like. So let's use a base of 2. So a shift to the right, again, horizontal stuff is going to be near the x. So x minus a number, that would be a shift right. Whereas a shift left would be plus a number, and it's in the exponent. A shift up would be outside away from the x. A shift down, again away, but it would be minus. Reflecting over the y-axis is going to be near the x. Reflecting over the x is away from the x. It's also important to note there that is not negative 2 to the x. That is not something that we are going to graph. We're always going to look at positive bases. All right, now let's look at log equations. Okay, so again, horizontal changes are going to occur inside the parentheses near the x. So that's a shift right. That's a shift left. A shift up, again, is going to be outside the parentheses. A shift down is going to be outside the parentheses. Reflection over the y-axis would be inside because that's horizontal. Reflection over the x would be outside. right, so all we're going to do to start is just identify what's the base, what are the transformations, and let's find the asymptote, because these are the things that we can't get from looking at a calculator. You'll notice if you do graph this on a calculator, you're not going to see the asymptote. So we need to make sure we can identify the asymptote. All right, so first of all, the base of the graph is what actually has the exponent. So on this first one, the base is 3. Transformations, that -2 in the exponent is a shift right. The +4 that's outside is a shift up. And we'll come back and do transformations, or let's go ahead and do the asymptote now. So for a exponential function, it's going to be a y equals asymptote. So exponential is going to be y equals. What it's going to equal is basically the vertical shift. Because if you think about the way the original graph looks, okay, if you shift it up or down, that's going to move the asymptote. So it's going to be y equals, and whatever you have added or subtracted at the end. So my asymptote is y equals 4. All right, let's try the next one. Again, the base is what has the exponent. It is not a -5 in parentheses. So the negative is not part of the base. The base is 5. What the negative out in front is a reflection. It's out away from the x, so it's a reflection over the x. Then we have a shift left 3 and a shift down 2. So down 2, that's going to be our asymptote, y equals -2. All right, try another. E is the base. And remember, E is about 2.718. Transformations, there's a negative next to the x, so that's a reflection over the y. And then we've gone up 6. Since we've gone up, that is our horizontal asymptote, so y equals 6. And then our last exponential, the base here, what actually has the exponent, is 10. This one has 2 negatives, all right? So the negative out in front, that is the reflection over the x. The negative that's up in the exponent, that is a reflection over the y. And then we've gone to the right 4. And then horizontal asymptote is y equals. There is nothing added or subtracted, so it's just y equals 0, just like the parent function. All right, same thing now. We're just going to do it for log functions. All right, again, we're going to start by identifying the base. So the base is just that little subscript number. The base on this first one is 3. Transformations, so we've gone right 1 and up 3. What's different here, though, this is a vertical asymptote. So it's a vertical asymptote, so it's going to be x equals. Now, what's a little bit different here is we can't just use the number that's on there. So since it's x equals, we're going to deal with the horizontal. And again, we have to do the horizontal stuff backwards. So what you do is you take what's in the parentheses, set it equal to 0. So my horizontal or my vertical asymptote is x equals 1. So for exponential, it's y equals whatever is added or subtracted. For log, you take the argument and you set it equal to 0. All right, let's do another one. So ln, the base of ln is e. Negative next to the x, reflection over the y. -3, shift down. So asymptote, so x equals whatever is in, or we set what's in the parentheses equal to 0. So x equals 0. All right, on the next one, our base is 2. Transformations, the negative out in front is a reflection over the x. And then we have a shift left 5. Asymptote, take what's in the argument, set it equal to 0. So x equals -5. And then last one, the base is not written, so remember that means a base of 10. Negative out in front is a reflection over the x, and this one's actually kind of tricky. I'm going to rewrite that. That is a -x plus 4. And if you remember, what we want to do is factor out that negative. So this is actually a reflection over the y and a shift right 4. And that one's a little bit tricky. But again, to figure out where the asymptote is, take what's in the parentheses, set it equal to 0. So I get x equals 4. All right, so what we're going to do now is we're actually going to sketch the graphs. Now, if you want to use a calculator to view the shape, that really could help you guys. But again, you're going to have to be able to identify that pivot point and the asymptote, and those are not going to show up if you try to graph it on a calculator. So it's important that we know what those things are. So we're going to start with exponential. All right, so what I'm going to do to start is I'm going to write the transformations. All right, I've gone right 3 and down 1. That 2 is not a vertical stretch, it's just a base. So all we have is right 3 and down 1. So the first thing I'm going to do is I'm going to do the asymptote, okay? Exponential, y equals the number at the end. So I'm going to graph y equals -1 as a dotted line. And that right there is probably the most important part of the graph, because the rest of it you can probably get from a calculator, but that part you can't. Now let's find the pivot point. The normal starting pivot point is 0, 1, because anything to the 0 power is 1. But we need to see how that point's going to look different. We're going to shift that point right 3 and down 1. So if I take 0, 1 and I go right 1, 2, 3 and down 1, that new location of that point is at 3, 0. So that is my new pivot point. Then again, at this point, you can either look at the shape on a calculator or you can say, hey, look, it has the same shape as the parent function. Domain, every exponential has the same domain. And then range, bottom to top. So the lowest y value here is the asymptote, which is at -1. It doesn't touch it, so it has a parenthesis. So -1 to infinity. All right, let's look at another one. Let's write our transformations. That negative up there is a reflection over the y. That -4 is a shift down 4. That tells us our asymptote. Y equals -4. I'm going to plot that first. All right, the pivot point. So typically our first pivot point, 0, 1. But what we're doing with that pivot point, okay, we are reflecting over the y. Well, if you think about the point 0, 1, if you reflect it over the y, it's still 0, 1. That hasn't changed. But we're also going to take that point and shift it down 1, 2, 3, 4. So there's my new pivot point. So the new pivot point is 0, -3. And again, you can check the shape in a calculator or just realize it looks like the parent function, but it's reflected over the y, so it goes in the opposite direction. Domain, -infinity to infinity, that has not changed. Range, again, bottom to top. The lowest y value is -4, and it goes to infinity. It's always a parenthesis at the asymptote. So you're going to see a lot of parentheses for these domains and ranges. All right, let's do 2 more exponentials, and then we'll look at logs. So again, let's write our transformations. Negative out in front, reflection over the x. Left 4, up 3. If we've gone up 3, our asymptote is y equals 3. All right, now let's find the pivot point. So I'm starting at 0, 1. I'm taking the point at 0, 1, and I'm going to first reflect. So if we have more than one thing, we're going to reflect first. So I'm going to reflect that over the x-axis. Then I'm going to go left 4 and up 3. So that is my new pivot point. So that pivot point is now at -4, 2. All right, and again, if you can check the shape on a calculator at this point, or just remember the original shape looks like this, so we're going to reflect that over the axis. Domain for every exponential, -infinity to infinity. Range, we go bottom to top. The lowest y value is -infinity, the highest y value is 3. It doesn't touch 3, so we put a parenthesis on it. All right, last one. Let's look at transformations. Negative out in front, reflection over the x. Negative in the parentheses, reflection over the y. So this one's going to be reflected both ways. And then we have a shift right 1. There is no shift up and down, so my asymptote is y equals 0. All right, let's find our new pivot point. Reflect first. So I'm going to take 0, 1. I'm going to reflect it over the y. Okay, that doesn't change it. I'm going to reflect it over the x. There's my new pivot point. I'm going to take it now and shift it to the right 1. So my pivot point now is at 1, -1. And again, check the shape on the calculator or just think, here's my original. Reflect it over the x and reflect it over the y. All right, again, domain for every exponential, -infinity to infinity. Bottom to top, -infinity is the smallest. The highest y value is the asymptote. You don't touch the asymptote. All right, we are almost done. We are now going to look at some log graphs. If my slide will switch, there we go. All right, whoops, too far. All right, so again, let's start by looking at our transformations. Left 2, down 1. That's going to affect the pivot point. Now remember, for log, the starting pivot point is 1, 0. So we're going to take that 1, 0. We're going to go left 2 and down 1. So my new pivot point is -1, -1. The asymptote, we're going to look at what's in the parentheses. Take what's in the parentheses, set it equal to 0. And then the shape in this one is going to look like the parent function. So for log, every log has a range of -infinity to infinity. The domain is based on the asymptote. So the farthest left is -2, and it keeps going to infinity. All right, let's look at another one. Reflected over the x, that's the negative out in front, shifted right 4. So if we've gone right 4, that's going to affect my asymptote. So again, you can think about this graphically. If it starts here on the parent function and we shift it right 4, okay, that's where your asymptote's going to be. If you want to do it algebraically, x minus 4 equals 0, so x equals 4. So that's my asymptote. The pivot point starts at 1, 0. We're going to take that point. If I take 1, 0, and I reflect it over the x-axis, that doesn't change it. Then I'm going to take that point and shift it to the right, 1, 2, 3, 4. So there's my new pivot point at 5, 0. The shape, it's been reflected over the x. So that's how it looks different than the parent function. Again, if you want to graph it to see that, you can. Range for every log is -infinity to infinity. But the domain is affected by the asymptote. So it's 4 to infinity. All right, 2 more. All right, so again, this one's a little tricky. I'm going to rewrite this as negative parentheses x minus 3. That makes it just a little bit easier to see the transformations. And this one's pretty tough. So all the things are happening in the parentheses. So that's a reflection over the y and a shift right 3. All right, so start with the pivot point, 1, 0. So 1, 0, we're going to reflect it over the y. And then we're going to shift it right, 1, 2, 3. So 2, 0 is my new pivot point. All right, asymptote. Okay, take what's in the parentheses, set it equal to 0. So x equals 3. And then since it's been reflected over the y, the shape it's going to have looks a little bit different than your parent function. All of our ranges for logs are -infinity to infinity, but the domain left to right. So -infinity until the asymptote. It doesn't touch the asymptote, so it needs a parenthesis. All right, last one. So again, this one has both a reflection over the x and a reflection over the y. It also has been shifted up 4. Pivot point starts at 1, 0. So let's see how we're going to change that. So we're going to take 1, 0. Reflect it over the x, that doesn't change. Reflect it over the y. Then we're going to take that point and go up 1, 2, 3, 4. So my new pivot point is -1, 4. Asymptote, take what's in the parentheses, set it equal to 0. So I get x equals 0. The shape of the graph, you can check on a calculator, or again, take your parent function shape, reflect it over the x, and reflect it over the y. So there's my shape. All of the range for logs is -infinity to infinity. Domain left to right is -infinity until 0. All right, so today, like I said, today is a little bit of a harder day, guys. Now remember, you can use the calculator to help you see the shape of the graph, but you do need to be able to find, most importantly, the asymptote. That is the most important thing for you to be able to find, and you are not going to see that on a calculator. So if nothing else, make sure you understand how to find the asymptote, and that also is going to help you be able to figure out your domain and range.